Kia ora koutou. This is the first video I've made for ages this year, and this one is for people doing my Saturday Maths Level 2 class. It comes from an amazing UK website called Dr. Austin Maths, and I'm really happy that Amanda has said it's fine for me to video her worksheets. So if you are watching this and you want some more practice on basically any of the stuff we've done in class on quadratics, this is where I've been getting lots of materials from, and I've put the URL in here. And if you go to that page, you'll get all of the links for worksheets and answers to different topics. So I'm just going to pick one of them here, which is a really nice worksheet looking at more complex factorising. It revises two things that we've seen a little bit of, which is factorising using a difference of two squares pattern and factorising using grouping. So I'm going to quickly do an example of both of those things, but if you want a slower version of that, go and find my earlier old videos on the Level 2 Algebra playlist. So the difference of two squares is a pattern that comes up over and over again in Level 2 and 3 Algebra, and this is the most basic case of it. Suppose that we've got x squared minus 64. You'll notice that in this quadratic, we don't have the usual middle term with an x, right? So there's nothing in this one that's got an x. In other words, the coefficient on x is 0. So you can see that x squared is a square, and also notice that 64 is a square. And that's your kind of big red light to say, stop, I've got a difference of two squares pattern. So we can factorise this as follows. X times x. Now I've got a minus here, so I must have a positive and a negative here. And now if we put an 8 and negative 8, look what happens. We get x squared plus 8x minus 8x minus 64. And we're going to use this in almost all of the 12 exercises in this video. Okay, so these are the 12 here. And then the other thing I want to go through also quite quickly is how we can use the grouping method to factorize quadratics when we've got ax squared plus bx plus c and a is not equal to 1. So one simple example, suppose that I've got 6x squared plus x minus 35. Just looking at that, there are only a few combinations that are going to give me minus 35. We could have 1 and negative 35, negative 1 and 35, 5 and negative 7, or negative 7 and 5. So that's not too bad. But for the 6x squared, we could also have x and 6x, or 6x and x, and then we could have 2x and 3x, or 3x and 2x. So what I'm saying is that some of you might be able to just look at that and see it straight away, how to factorize it, and that's a really good skill to have. But if you're not at that point, then using the grouping method is a good thing to do here. So when we do grouping, what we're trying to do is to break up this middle term so that we can easily factorize in two steps. What we're going to do is say, well, we want two numbers that multiply together to give me this one, the a times the c. So 6 times negative 35 is 3 times negative 70, so that's negative 210. And we need the two numbers to add together to give me 1. So when I get a tricky one like this, sometimes what I will do is a little prime factor tree like we did back in year 9, and I'm waiting for something to jump out at me. So if we take 210, we know that it's 21 times 10. So it's worth looking at those two numbers and going, is there a way to get a gap of 1? No, there's not. So let's now go, 21 is 7 times 3, and 10 is 2 times 5. Let's see if we can see a combination of those factors that will generate this gap of 1 that we need. Well, we've got 7 times 2 will give me 14, and the 3 times the 5 will give me 15. So if we put those in here, we have 15 plus negative 14 will give me 1, and 15 times negative 14 will give me negative 210. That means that we're ready to go. So we've got 6x squared plus x minus 35 is equal to 6x squared. I can pick either of these. I'll do 6x squared plus 15x minus 14x minus 35. And now I'm going to factorize the first two terms and then factorize the second two terms. So factorising 6x squared plus 15x gives me 3x times 2x plus 5. Over here, the highest common factor is 7, so I've got minus 7 into 2x plus 5. Now you can see that this is repeating, and if it's not repeating, you've done something wrong, right? So that means that the whole thing factorizes to give me 3x minus 7 times 2x plus 5. Now we don't use that very much in this exercise, but it comes up once or twice, and it's a really crucial method to have at your fingertips for level 2 algebra. So let's now go back and look at these questions. And what I'd like you to do now is to pause the video, and using the two ideas of difference of two squares and grouping, try and work your way through as far as you can, and then I'm going to go through them. There'll probably have to be a part 2 for this video because I've used up 6 minutes already. Okay, so before we get started, I'm just going to look quickly at all 12 and show you how we can spot which ones might be a difference of two squares straight away. This time we've got x's and y's, but this one here has got no mixed up term with both x and y in it. So that one's going to be a difference of two squares. These ones look funny, 2 and 3 look funny. This one's going to be a difference of two squares in some form. So is this one, so is this one. And to start with, that looks like that might be all. But when you look a bit more closely, you can see that this one here is also going to be a difference of two squares, because I've got a squared thing here minus a squared thing here. It's just that the square things now are more complicated than when we just had x squared minus 64. So that one's going to be a difference of two squares, and so is this one. And the other ones look like they might be something a bit more complicated. So I'm going to pick off those questions and go through those first, and I'm going to save the other ones for part 2 of the video. So question 1, 4x squared minus 9y squared factorizes to give me 2x here, and this is equal to 3y times 3y. So 2x plus 3y times 2x minus 3y. Right, so remember what I'm doing is I'm looking at this term and I'm seeing what is the square root of 4, it's 2, and what's the square root of x squared, it's x. The same thing here. Question 4, 4x squared minus 36y squared, same idea, 2x plus 6y times 2x minus 6y. When we move on to 5, we can see that it's got a little bit more interesting and a little bit less obviously a squared. So we've got 4x to the power of 4 minus 9y to the power of 6. Now there's no square in here, but we've got an even power. So this is equal to 2x squared times 2x squared, right? Remember my rule about adding the powers when we're working with indices, right? So this x squared times the x squared is going to give me x to the power of 4. And that helps me with this. 9y to the 6th is equal to 3y cubed times 3y cubed. So this factorizes to 2x squared minus 3y cubed, or we'll stick with our usual order, 2x squared minus 3y cubed. In question 9, we've got another variation on that. So 4x cubed minus 9xy squared. Always look first at your coefficients or your numbers to look for common factors. There aren't any here. Both of these are square numbers. And then systematically check your variables to see if you've got a common factor. In here, we've got x cubed, and we've got x here. So there's a common factor in this whole thing of x. Once we take that out, it's obvious that we're back to an easier difference of two squares problem. So we have x times 2x plus 3y times 2x minus 3y. So that's question 9. Now let's look at these two ones that I've circled in the pink. So this question here, question 6 and question 10, are ones where the thing that's being squared is not just an x or a y or a number. But if you understand the principle of difference of two squares, these are really pretty straightforward. So we've got 2x plus 3y squared minus x minus y squared. So this will equal 2x plus 3y plus x minus y, and I'm leaving those brackets there for now, times 2x plus 3y minus x minus y. So let's go over again what's going on here. This is as if I had a squared minus 49, right? This is our basic pattern, and it works because I'm adding this bit and then I'm subtracting the same thing. So that works exactly the same way as long as I've got a thing squared here and another thing squared here. All we have to do to finish this one off now is just clean up what we've got in each of those brackets. So in the first bracket, I've got 2x plus x, so 3x, and now I've got 3y minus y, so that leaves me with 2y. And in here I've got 2x minus x, which gives me x, and then 3y minus negative y plus 4y. So that's that one done. Now I guess we could expand that if we wanted to. Let's do that. This exercise is originally a matchup, and I can't remember what's on the other side of the matchup, but if you go to the website and find the worksheet, you'll see the matchy-uppy stuff. So 2x squared plus 2xy in here, plus 12xy from these two, plus 8y squared. So cleaning that up gives us, let me just get rid of this. What does that give me? 3x squared plus 14xy plus 8y squared. Okay, so that's that expanded, or I think it would be fine to leave it in factorized form. It would depend on what you needed to do with that expression if it were inside another problem. And then just one left to do before I stop for this video, and that's the same kind of thing, which is question 10. I'll just get some space. Right, so question 10, we've got 2x minus 3y squared minus x plus 5y squared. So it's going to be 2x minus 3y plus x plus 5y times 2x minus 3y minus x plus 5y. Cleaning it up, we get 3x plus 2y times x minus 3y minus 5y gives me minus 8y, I think. Now, I'm sure that one of you guys is going to tell me if I've made a mistake with any of those. I'm just checking that it matches what I did when I did these last night, and it looks fine. Great. Okay, so that's the first video. I'm going to do another video going over these ones here. 1, 2, 3, 4, 5, 6 more questions. So that should be up soon. Please let me know if you find anything, any mistakes in this or anything is not clear. Just send me an email and I will get back to you.